Okay, two particles A and B, each of mass 1.1 kilograms, 1.4 kilograms, are attached to the ends of a lighted strip. The mass A lies on a smooth horizontal table. The string passes over a smooth pulley at the edge of the table. System is released to rest with B hanging vertically. Calculate the acceleration of the system. Okay, because this is a smooth table, the only force acting on A is T. So we have, using Newton's law, F equals ma, so the only force acting on that is T, and that must be equal to its mass 1.1 times its acceleration. So that was at A. And then if we look at B, there's two forces acting on it, and it's going to fall down, so we've got 1.4 G acting down, take away the tension, is equal to its weight times its acceleration. Now the key thing we've got to remember here is, because they're connected with the taut string, if one's accelerating at A, the other must be accelerating at A as well. If we add the two equations together, we get 1.4 G equals 2.5 A, and if we multiply that out, we get 1.4 times 10 equals 2.5 A, so A is equal to 1.4 times 10 divided by 2.5, so that works out to be 5.6. So A turns out to be 5.6 meters per second squared because it's an acceleration. Okay, then we're asked for the tension, and we can find that by just substituting back into that first equation. So T is equal to 1.1A, so the tension is going to be 1.1 times 5.6. Okay, the calculator tells me that's 6.16, and this is force, so it's newtons. Next we're asked, what's the force exerted by the string on the pulley? Now we need to have a little diagram here. So if we've got the pulley, there's two forces acting on it at the minute. It feels the string pulling down on it there, and it feels the tension of the string pulling back on it there. So the force it feels is going to be, both of those forces are going to pull in that direction. Now because it's symmetry of the thing, we know each of those angles is 45 degrees. So if we resolve those two forces, what we're going to get is, from the top force, we'll get a force T cos 45 down, and pointing out this way we'll get a T sin 45. And then if we look at this string, again we're going to have another T cos 45 pointing into the pulley, and pointing down we're going to have T sin 45. Now obviously these two are going to cancel each out, so as far as the pulley is concerned, it's going to have these two forces, 2T cos 45. So the force on the pulley is equal to 2T cos 45, so it's 2 times 6.16 times cos 45, and if we go to our calculator, 8.71 newtons. Okay, the last thing then we're asked for is the distance travelled by B after 0.5, assuming it doesn't reach the ground. Okay, so we've got the acceleration, we worked out as 5.6. It starts off from rest, so U is 0. Its time taken to travel is 0.5, and we're looking for S. So we're going to use S equals UT plus a half AT squared. Okay, so we're going to have S is equal to nothing plus a half times 5.6 times a half squared. Okay, and we'll go to our calculator. That turns out to be 0.7 meters.